In this video, we're going to be looking at how trigonometry is applied in the unit circle. The learning intention of this video is for us to understand how trigonometry is related to the unit circle. We're then going to be evaluating, meaning to find out what are the values for the sine, the cosine, and tangent of any angles found in the first quadrant. And lastly, we're going to then determine whether the sine, cosine, and tangent of any other angles that's outside of the first quadrant gives you a positive or a negative answer. So the very first thing that we're going to be looking at is just to quickly review again of what trigonometry is. So previously during our first semester, when we looked at trigonometry, we were mainly working with the right angle triangles, and we used trigonometry for us to solve what was the unknown side lengths as well as the unknown angles inside of a right angle triangle. So let me test your understanding of what you guys can recall. So I've got 3 triangles down below, and in each of these right angle triangles, I want you to identify which trigonometric ratio would you be using to solve for the missing side length. Are you going to be using sine, cosine, or tan? So give yourself a minute to answer each of these triangles and we'll go through the answers together. So for the very first one, guys, in order for you to answer any of these questions, what you should be doing is you should be trying to label the side lengths as opposite, adjacent, and hypotenuse, and based on that, then you can kind of identify which ratio you'd be using. So in this case over here, x is my opposite. This over here is my adjacent, and that's my hypotenuse. Hypotenuse is always going to be the longest side length in a right angle triangle. Opposite will always be the side length that's directly across from the given angle, and adjacent is always going to be the one either next to the angle, that's how I remember, or the missing angle from after you found out the other two. So in this case, since I know my opposite as well as my adjacent side lengths, it makes sense for me to be using tan in this case over here. For my second triangle, I've been given my adjacent as well as my hypotenuse, so therefore I'll be using cosine, okay, because it gives me my adjacent as well as my hypotenuse. And for the very last one, this is giving me my opposite as well as my adjacent, so therefore in my last example I'd also be using tan as well. And I'm hoping that this is now going to you know, refresh your memory a little bit. So I'm just going to quickly review again of what we've done in the last lesson and then explain how is it related to trigonometry. So if you guys can recall, we said that a unit circle is a special circle that has a radius of 1, and that's the reason why you can actually label these coordinates like so. And we know that a unit circle is also divided into 4 equal parts, and they are referred to as quadrant 1, 2, 3, and 4, and they go anti-clockwise when you measure a positive angle, and it always starts from this particular coordinate over here, okay? Now, although the unit circle is clearly not a triangle, we can still use trigonometry for the unit circle. But instead of using trigonometry to find what is the missing side lengths or missing angles, we use trigonometry in this particular unit to find the coordinate of a point or any point on the unit circle. So what do I mean by this? So what I could do is I could actually find out what is this particular coordinate here. I could find out what is this particular coordinate, or I could find out what is this particular coordinate. Okay? I can find out the coordinates of any position along this unit circle by using trigonometry. But for now, let's just look at for this particular angle over here, okay? So if I knew what this angle was, okay, let's say that's 35, 40. If I know what that angle is, I could actually find out the exact value of this coordinate. Just for the general case over here, for the general purposes, I'm just going to say that the angle is going to be theta, but generally the question would give you what the angle is. So regardless of what the angle is, I could actually find out the values of x and y. Now, I do want to point out that this x and y, don't get confused with these x and y's, okay? The x and y's over here represent, obviously, your x and y axes. The reason I've provided this as x and y is because we often use x to move in the horizontal direction. So that's what I've drawn over here. It's moved x units to the right, and it's moved y units in the y direction, the positive direction along the vertical axis, okay? So that's why I've denoted this as x and y as well, because you're more familiar with these pronumerals. So as I said, we could actually find out what are the exact values of x and y. But instead of like using these x and y pronumerals instead, we could actually express these pronumerals in terms of trigonomic ratios. So what that essentially means is instead of using the letters x and y, we can convert that and change it into sine, cosine, or tan. And I'm going to show you how this is done, okay? So we can clearly see that this is a right angle triangle, but I'm just going to zoom in so that you can see this more clearly. So zooming in right now, okay, we could actually use trigonometry to find out, well, what is the horizontal distance that you've moved and what is the vertical distance you moved to get to this particular point over here. And that will tell me what is the exact values. So to find out the horizontal side length, I need to identify, am I going to be using sine, cosine, or tan? In this case over here, because I want to find out my horizontal, so this one over here, I want to find out what this is. I've already been given what the hypotenuse is, because remember that the unit circle has a radius of 1. That's why this distance over here is going to be 1. Since I know that one, I can therefore use cosine in this case, because that's my adjacent, that's my hypotenuse, so therefore I could be using cos. And we know that cos is adjacent over hypotenuse, so if I substitute the values into the formula, it will be x divided by 1. But you already know that if you divide any numbers by 1, that's essentially the same number, okay? So we can kind of ignore that, and that's the same thing as writing x is therefore equal to cos theta. So what I've done is I've converted the x value of the coordinates in terms of a trigonomic ratio. In this case, that's cosine. So if you wanted to find out what is the vertical, so that's what this value is, you could also use trigonometry as well. So if you want to find out what this is, you've been given what this side length is. So in this case, that's your opposite. So opposite hypotenuse, that relates to sine. So therefore, if you substitute those values in, it'll be y over 1. But remember, any number divided by 1 is still the same number. So that's the same thing as writing y is the same thing as, or it's equal to sine theta, okay? So what does this mean? So because that you know that x is equal to cos theta and y is equal to sine theta, you can actually just replace x and y in this particular diagram over here. So that's what I've done. Okay, so I've just replaced y with sine theta and x, which is the horizontal distance, as cos theta. And therefore, this coordinate over here, instead of writing x and y, I could write that coordinate as cos theta, comma, sine theta, okay? At the moment, it's a bit arbitrary, so it's a bit hard for you to understand. It's quite abstract. But when if I actually give you a proper angle, this will start to make a bit more sense. Now, you're probably thinking, all right, in the context of the unit circle, what does tan represent? We've already talked about sine. We've already talked about cos. What does tan mean in this particular case over here? So in this case over here, remember that tan is opposite over adjacent. In this case over here, your opposite is your sine, okay, because that's directly across, and your adjacent is equal to cos. So therefore, if you substitute that into the formula, the rule for tan is that is equal to sine theta divided by cos theta. So if you know what sine theta is equal to, and you know what cos theta is equal to, you substitute that values in and then just simplify using a calculator, and that will give you the answer for tan theta, okay? So just to summarize what we've talked about, in circular functions, which is the topic that we're doing for this unit, trigonomic ratios have a slightly different definition, okay? Because we're not really dealing with triangles, we're just dealing with the unit circle. Cos theta represents the x-coordinate, whereas sine theta represents the y-coordinate of a point on the unit circle with an angle theta between the positive x-axis and the radius to the point. This is very complicated, but essentially what that means is regardless of where the point is, whether it's up over here, whether it's over here, the x value of that particular point will always be equal to cos theta, and the y value of that point will always be equal to sine theta, okay? And what this part over here, that second half, just means that you're just measuring the angle from this side going in an anti-clockwise direction till you reach, that particular line, that radius over there. So in order for you guys to help you memorize whether x is sine or cosine or not, this is my useful tip to you guys, okay? So we know that in the alphabet, x goes before y, right? So Similarly, you can actually use that kind of, I suppose, relationship to see whether that x corresponds to sine or cosine. In this case, if you out of all your trigonometric ratios, you've got sine, you've got cosine, and you've got tan. While c goes before s or t, so therefore cos will therefore be related to your x value, okay, because x goes before y. And the next one that follows alphabetically will be sine, so therefore that connects with y. And tan is pretty much by itself. Doesn't really provide, I'd say for now, that much useful information in terms of the coordinate of the actual point. Let's now look at some specific examples where I actually give you the exact value of the angle so that we can actually work out what are the coordinates on the unit circle, okay? So in this particular example, in the first example over here, the angle in this case is 0. You can kind of see that because you haven't actually rotated it off from this initial starting point. Don't worry about what this yellow text over here is. And over here, it kind of tells you what the answer is, but I'm going to show you how I actually arrived to the answer, okay? So in this case over here, remember the main thing that you need to understand is that the x value of the unit circle corresponds to cosine, and that the y value represents or corresponds to the sine theta in this case. And because theta is equal to 0, that's the reason why I've included 0 over here, okay? Now, in order for you to identify for this particular example, which is a simple example, I don't actually need to use my calculator at all. I could actually just find out what the answer is by just using a bit of common sense and interpreting the information from the actual diagram itself. Okay, so for this particular point, because that's what I'm trying to do, what is the exact value of this particular point over here, okay? In this case over here, remember that I told you that the unit circle is a special circle where the radius is equal to 1. In this case over here, I can clearly see that my x value is going to therefore be 1 because that's the radius, okay? So therefore, this is going to be 1. So that's going to be 1 over here. And you can clearly see that your y value, okay, which is your sine value in this case over here, that corresponds to 0 because you're not actually moving vertically at all. So therefore, the coordinates for this one is going to be 1, 0, okay? But you could also take I suppose, the trigonometry approach to see whether the answer is correct as well. So remember how I said cosine is equal to x in this case over here. If you do want to actually put that into the calculator, what does cos 0 equal to, and make sure that you put this into degree mode. If you put this into degree mode into your calculator, you should get an answer of 1. Similarly, if you put in sine 0 degrees into the calculator, which corresponds to the y value, that will equal to 0. So therefore, remember that you're trying to find out what are the x and y values, so you can put these coordinates back into this form over here and notice that you still get the same answer. So there are two approaches you can do. So for the very simple ones, you can kind of use a bit of common sense, but if you can't really get the answer like this, then you will need to use a calculator sometimes to get the answer, okay? Now, in order for us to find out what is the tangent of 0, remember that tan is found by going sine of the angle divided by cos of the angle, okay? So therefore, if I substitute the answers for sine and cosine into the formula, therefore it would be 0 divided by 1, and in this case over here, 0 divided by any number is going to be 0. So therefore, tan of 0 is going to be equal to 0. So that's the first example. Let's go through a slightly more challenging example. So in this case over here, the angle in this case is equal to 60. So we're trying to find out what are the exact coordinates for this particular point over here, which is denoted by x and y. This is again giving the answer, but we'll see whether that's the correct answer or not. So in this case over here, we could use trigonometry to do this, okay? So if you wanted to find out what is your x value, in this case over here, we just use the ratios. Remember that cos is, the x value is always going to be equal to the cos of the angle. So if you put in cos 60 degrees into the calculator, you should get an answer of half exactly, okay? There is no rounding up. You should get you 0.5 exactly. Do the same thing to find out what y is. So remember, y is equal to the sine of the angle. So if you just go sine 60 degrees into the calculator, that will give you the y value in this case, and that will give you root 3 on 2. And if you convert this into a decimal, then you round up to 2 decimal places. That's roughly going to be equal to 0.87. So that's going to be, therefore, the coordinates for this guy over here, okay? Now, this is not answering the question, but similarly, you can also find out what is the tangent of that particular angle as well. So if you substitute your answers for sine 60 and cos 60 into the formula, then divide this, then you will get an answer of 0.32, okay? And for the very last example over here, again, this is another angle found in the first quadrant. In this case, the angle is going to be 90 degrees. This case, we don't actually have to use trigonometry at all. To find out the answer of this one, you can kind of just eyeball it graphically. In this example over here, you're trying to find out what is the value of this particular coordinate. Well, we know that the radius of this case over here is going to be equal to 1. So that means that's going to be equal to your y value. And because you haven't moved horizontally at all, you're still staying at the origin. That's therefore going to equal to 0. So therefore, that's going to be your answer. Okay, but obviously you can use trigonometry and use the calculator to do this. So we know that x is equal to the cos of the angle. Find out what is cos 90. That's going to give you 0. Find out what is sine 90. That will give you 1. So therefore, that's going to be the coordinate. And you can do the same thing, to find out the tangent as well. So now I want to give you 3 minutes to answer this particular question over here. You will need a calculator in order to solve this. So give yourself 3 minutes and then we'll compare our answers together. If you guys have done this successfully, what you should have done is you should have maybe draw a triangle out to find out what this is in this case over here. Remember that the x value of the coordinate is always going to be equal to the cos of whatever angle. So if you go cos 80 into the calculator, you're going to get 0.17, okay? And that kind of makes sense because notice over here, you haven't moved too much. And remember, this full length is equal to 1. But in this case over here, you notice that you moved quite a bit of distance in terms of the vertical direction. So it's going to be slightly under 1. So to find out the y value, just go sine of 80. And if you do this, you're going to get 0.98. And again, notice that this value is very close to 1, which is the radius within the unit circle, okay? And since you found out the values of x and y, just write the coordinates in. So therefore, you'd write the coordinate of point P is 0.17, 0.98. All right, so far we've pretty much have been evaluating angles found in the first quadrant, but you could also find out what is the sine, cosine, and tangent of other angles found in other quadrants, okay? But this can only be done by hand for certain angles only, okay? And the ones where you can actually do it by hand are angles that have multiples of 30, 40, 60, or 90. So for instance, 120, well, we know that 30 can go into 120, 60 can go into 120 as well. In terms of 135, that's a multiple of 45. And all of these other examples over here, these have either multiples of 30 or 45 or 60, etc., okay? And these are the ones that you can do without using calculators at all. Any angles other than these angles that have been given into this unit circle, then you're going to need to use a calculator in order for you to actually find out. And we will be doing this in future lessons, so don't stress about this for now. We're going to be moving towards the last part of today's lesson, and that's finding whether sine, cosine, tangent of any other angle that's pretty much outside of the first quadrant will give you a positive or a negative answer, okay? And there are 2 particular ways for you to do this. We can do this the conceptual way, which is, I suppose, the longer way, but this way is what makes sense. The second method doesn't have any explanation to it at all. You just have to memorize a few facts, but that is obviously a more short way. But I'll show you 2 ways, and I expect you guys to understand how to work it out using both of these approaches. So in order for you guys to know whether the sine or cosine is a positive or a negative answer, what you need to do first is you need to identify where that which quadrant the angle lies in. And once you've done this successfully, the second step is you need to therefore examine on the unit circle whether x or y is negative or positive. Now that probably doesn't make sense at all, but I'll show you using these 2 examples down below. So the question reads, state whether sine 174 is positive or negative. So firstly, first step says identify which quadrant this lies in, okay? And usually these questions don't give you the unit circle at all, but it might be helpful for you if you draw a mini unit circle to answer this question. I know that 174 lies over here, so therefore this lies in the second quadrant, okay? Now, the trig ratio, the trig function that the question has given me is sine. Now, remember, sine corresponds to the y value, okay, along the unit circle, okay? So it's talking about the vertical distance over here. So in this case over here, because it's talking about vertical, we look at this particular coordinate over here and say, well, is this y value for this particular coordinate a positive number or is it a negative number? And in this case over here, because it lies above the x-axis, therefore this gives you a positive answer, okay? And if you can also double check this as well by putting this to a calculator, you can just put this in, and if you did this in, you will notice that you are getting a positive answer. So therefore this kind of backs this up by saying that this answer is positive. So all you need to do for this answer is just write positive. You don't have to prove it at all by using a calculator. And for the second example, cosine of 230 degrees, find which quadrant 230 degrees belongs in. 230 degrees in this case belongs in quadrant 3. And in this case, because it's talking about cos, remember cos now refers to the x value, okay? So it's talking about the horizontal distance in this case of that coordinate relative to the origin. So in this case, we're talking about this x value of the coordinate. So it's asking you, is this x value positive or negative? And because the origin's over here, this over here indicates that your x value is going to be a negative value, okay? So therefore the answer of this is negative, and you could also double check by putting this into the calculator, and if you do, notice that you are getting a negative value, okay? So you're probably thinking now, okay, how do you find what is a tangent then, okay, using this method? And it's you're not really doing anything different. All you're really doing is you're going to be substituting the values of sine and cosine into the formula, and then just to check whether that ratio, when you divide it, gives you a positive or a negative answer, okay? So let's go through one example together. So the question reads tan of 100 degrees, is that positive or negative? In this case over here, I need to find out whether sine 100 as well as cosine 100 is positive or negative. So 100 degrees lies in the second quadrant, okay? So roughly around there. Remember, sine in this case over here refers to your y value. So looking at this y value here, is it a positive y value or a negative y value? This is clearly a positive y value since it's above the x-axis. So therefore, sine 100 degrees is going to be positive. Cosine represents the x value. In terms of the x value here compared to the origin, this is going to be a negative value, okay? And I don't need to find out what the actual values are. And if you substitute this back into the formula, if you go a positive number, any positive number divided by a negative number, well, we know that in this case, that's going to give you negative, okay? So therefore, this is the answer over here. So just to reiterate, all you do is find out what is the sine and cosine for that particular angle, put those values or that the charges into the formula and see what the ratio gives you. What I want you to do now is I want you to have an attempt. So give yourself 3 minutes and then we'll compare our answers together. If you guys have done this successfully, for the very first one over here, 300 degrees lies in the fourth quadrant, okay? And remember, sine refers to your y value. We can clearly say that your y value relative to the origin is going to be negative. So that answer is going to be negative. 240 degrees lies in the third quadrant, and cos represents your x value. And in this case, your x value is going to be negative relative to the origin. And for the very last one, tan 145 lies in the second quadrant. In order for you to determine whether this is going to be positive or negative for tan, you have to find out what is sine 145 as well as cos 145. Remember, sine is your vertical. So in this case over here, that's going to be positive. But in this case, cos 145, which is your x value, is a negative. So if you go positive number divided by negative number, that's going to give you negative over here. Now, if this method doesn't make sense to you at all, you could use the shortcut method over here, okay? And all you need to do in order to use this method is just memorize or have this in your cheat sheet at the very least, because this tells you which quadrants are positive and negative for sine, cosine, as well as tangent. So in the first quadrant, regardless of whether you're using cosine, sine, or tan, if the angle is between, 0 to 90 and it belongs in the first quadrant, this will always give you a positive answer. If it's in the second quadrant, so if it's between 90 and 180, okay, sine of those angles will always give you a positive answer, but cos as well as tan, that will give you a negative answer for angles found in that quadrant. In the third quadrant, between 180 to 270, tan will always be positive, whereas sine and cosine of those angles will give you a negative answer. And for the last quadrant, between 270 and 360, cosine of those angles will give you a positive answer, whereas sine and tan will give you a negative answer. So now let's use an example to see whether we can answer this. So sine of 111 degrees, that lies in the second quadrant. According to this, all sine values are positive, and since I am looking for sine, therefore this will give me a positive answer. The second example, cos of 222. 222 lies in the third quadrant, this says over here all tan values are positive, and because I'm not out looking for tan, therefore our answer is going to be negative. And for the last one, tan 333, that belongs in this particular quadrant over here, and because I'm looking for tan, not cos, therefore my answer will be negative. And a way to memorize this particular acronym is by using this mnemonic over here. So remember, you always read it in an anti-clockwise direction when you measure an angle, so you can read it as a smart trig class, just to help you memorize, okay? It might work for you, it might not work for you. Have a go with answering these questions over here, and we'll compare our answers together. So for the very first one, 200 degrees, that lies in the third quadrant, so therefore the answer is going to be negative. This is a trick question over here, so remember, when you've got a negative angle, it's going clockwise as opposed to anti-clockwise, so therefore this would lie somewhere around over here, and because it's in the fourth quadrant, cos is going to be therefore positive. And for the very last one, tan 18 degrees, that lies in the first quadrant, so it's going to be positive. Alright, so now that we've gone through all the content, I would like you to please answer these questions over here. If you're wondering where is question one was found in the previous video. So you've got these questions over here. It shouldn't take you too long at all. This is pretty much the end of today's video. Hopefully you're able to meet the success criteria. Thanks for watching. I'll see you guys again in the next video. Bye.